Right, okay, so we're going to look now at synthetic division, which is the method that I tend to use for factorising a cubic polynomial. I am going to show you where this comes from quickly first. However, I understand you might just want to know how it works and what to do for it rather than like where it actually comes from. If this is the case, I will put in the link kind of at what time I start doing the actual work rather than the explanation of why it works. Okay, so what we do is we're assuming that we have a polynomial f of x, and instead of giving it actual numbers, it's ax to the 3 plus bx squared plus cx plus d. Okay, so what we're doing is we're putting it into nested form. Okay, so to do that, we take out the common factor of x out of the first three terms, giving us ax squared plus bx plus c, and then we're adding d. Okay, and then we take out x again, so we get ax plus b plus c plus d. Okay, so we can kind of rearrange that to be, so we're putting the ax plus b times by x plus c all times by x plus d, and this is the nested form, and this is a nice way of, if we're working with a polynomial, to be able to work out our coefficients, right? So what we have, so instead of just numbers, we're going to have f of x, just letters, even we're going to put numbers in. So we're going to have x cubed plus 7x squared plus 14x plus 8. And in this case, we're going to be asked to like evaluate f of 2. Okay, so this is not saying that we're factorising yet. It's just saying that we've got to find what the f of 2 is. We could do like 2 cubed plus 7 times 2 squared plus 14 times 2 plus 8. Okay, or we can kind of put it into this nested form that we've got above there. So we have ax, a is just 1 because there's a number in front of our x squared, plus b, which is the number in front of your x squared term from the start, all of that times x, plus c, which is 14, and we've got to times that by x, and then we've got to add 8. Right, so when we substitute in 3 into there, what we're doing is we're doing 3 plus 7 times 3 plus 14 times 3 plus 8. So you can see like we're starting with the coefficient of our x squared, like our x cubed, and we're adding that to the value we've got. So we're doing like 3 plus 7, which is 10, and then we're doing 10 times 3, and then once we've done that, we're then adding 14, then we're timesing by 3, and then we're adding the 8 again. So it kind of makes it, there's lots of timesing by 3s until you get to the end. When we do that, we're going to end up with 10 times 3 plus 14 times 3 plus 8, which gives us 30 plus 14, which is 44 times 3 plus 8, which is, then once we put that in, we get 140, right? Okay, so for those of you who didn't want to watch the explanation of kind of where this comes from, this is where to come in, and we'll be going through how to actually work synthetic division in a second. Also, I realised I said I was going to evaluate f of 2 and I've just evaluated f of 3 all the way through. I apologise. I'll just change that. And then we'll move on. Right, okay, so we're going to go into kind of how that helps us now. So, if we've got f of x, we'll use that same function there, equals x cubed plus 7x squared plus 14x plus 8. Okay, with synthetic division, what we're doing is we're setting up a table, and our table is going to use our coefficients of our values. So we start at our x cubed, then we put down our x squared, then our x, and then our constant. So it's this bit here, let's see, is our, so these here, don't know why sometimes this works and sometimes it doesn't. Sometimes it leaves it black on the top, sometimes it doesn't. So write it over the top, x cubed, x squared, x and c. These are decreasing powers of x. Okay, so that's what we're always doing when we're doing synthetic division. We always put them in order of decreasing powers of x, and you can't miss any powers of x. Okay, our next kind of column in our table is our coefficients. So next in goes our coefficients. So our coefficients for this one, for our x cubed, we've got a coefficient of 1. For our x squared, we have a coefficient of 7. For x, we've got a coefficient of 14. And for c, we have a coefficient of 8. Right? Okay. And we pick our number, so we're still going to try and find f of 3. Okay? Right, so we've got our coefficients, and what we need is the number we want to put in. So we put our, over here goes our, it's not our factor, well it's the inverse of our factor, it's to do with our factor, it's the number we're putting into our function. Okay, and the steps we do when we move the 1 down here, okay, and then we're going to add when we're going vertically, okay, and multiply diagonally. Right, for now, this is where you have to trust me and just follow along. Trust me, it is easier than long division in the long term, right? So, we have to take the 1 up here and multiply it by the factor, or that number there, so we're timesing it by 3. So we get 3. And then when we're going vertically, I need to add those two together. So I get the 7 plus the 3, which is the 10. Okay, then I need to move that over and times it by 3, times it by the number that you've got as the number you're putting into your function. Okay, so then we've got 10 times 3, so we have 30. Then when we're going vertically, we need to add, so we get 44. Okay, and then when we're going across, we multiply, so 44 times 3, which is going to be 132. Okay, and then in here we get 8 plus 132, which is 140, which is what we had before. So that is telling us that when we put 3 into that function, 140 is our answer. Okay, so this is a way of doing synthetic division to get our answer by just doing it step by step rather than having to go through it. If you can understand where the nested form comes from, that's fine. If you don't, that's okay as well, and you can just like work through it as like step by step, just knowing that you do the decreasing powers of x, the coefficients, you add vertically and you multiply diagonally. Right, so we'll do one where we're going to factorize fully. Okay, so we want to fully factorize, and we'll find out how this actually helps us factorize as well. Right, so we're going to fully factorize, and it's going to be f of x equals x cubed plus 3x squared minus 13x minus 15. Okay, and it's given x plus 1 is a factor. Okay, so that means if x plus 1 is a factor, okay, then f of minus 1, because remember we changed the sign, would be 0. So we can do this synthetic division thing, and as long as we get our remainder is 0, then we have a factor. And this does, the synthetic division actually gives us our quotient as well, so the number that we're going to multiply by. So we've got our x cubed, our x squared, our x, and our constant. So the coefficients of those are, this one, 1, 3, minus 13, and minus 15. And then we've got minus 1, which is what we're multiplying by. We bring the first one down. We multiply, so we're multiplying this time by minus 1. So we get minus 1 in here. And then we have to add these two together. So 3 plus minus 1 is 2. Multiply that by minus 1. And we're going to get minus 2. When we add those two together, we're going to get minus 15. We times the minus 15 by minus 1. We get 15, positive 15. When we add those two together, we get a remainder of 0. Okay, so we need to write something saying, proving that we've got a remainder of 0. Okay, since f of 1 minus 1 is equal to 0, x plus 1 is a factor. Right, so this line down here actually tells us our coefficients for what we've got left. So this is now our constant, so everything kind of moves up one. This is our constant, this is our x, and this is our x squared. So f of x equals x cubed plus 3x squared minus 13x minus 15. Okay, so we know that's equal to x plus 1, and then we've got times by x squared plus 2x minus 15. Those are coming from down here, so that's now our x squared, that's our x coefficient, and that's our constant. Okay, it would be the same up there, but we'd have a remainder, so it doesn't really work. And then we can factorize the second bit. So we've got x plus 1 times by, and then in our brackets, the x squared has to be an x and an x. The minus 15 has got to be, one's got to be a plus, one has to be a minus to get the minus 15. And to pick numbers that are going to give us 2, it's going to have to be a 5 and a 3. And it's going to have to be plus 5 minus 3. And that is that fully factorized. Okay, I will do another example using the synthetic division method, and don't worry, there'll be lots more examples to come as well. Okay, so the next example we're going to do is we're going to have x minus 2 is a factor of f of x equals x cubed minus 7x plus 6. So factorize fully. Right, so we need to set up our synthetic division table. Okay, so we've got x cubed we have x squared, we have x, and we have a constant. Never forget, just because there's not an x squared value doesn't mean that you miss it out on your synthetic division table. That's really important. So x cubed has got a 1 in front of it. There are no x squareds. We've got minus 7 x's, and then we've got 6 as our constant. Okay, our factor is minus 2, so it's 2 that we put out here. Okay, so this is because if f of 2 equals 0, then x minus 2 is a factor. Okay, so we bring the 1 down, we times the 1 by our number that's outside, which is a 2, so we get 1 times 2, which is 2. We add those two together, remembering we add vertically and we multiply diagonally, so we get 2. Then we've got 2 times 2, which is 4. Then we add minus 7 plus 4 is minus 3. Minus 3 times 2 is minus 6. Add those together, you get 0. So therefore, x minus 2 is a factor. Okay, because the remainder is 0. Okay, so then f of x is equal to x cubed minus 7x plus 6, which is equal to x minus 2 times by, remember this is giving us our x squared, our x, and our constant, the coefficients that is, so we've got x squared plus 2x minus 3. So then we've got x minus 2, and then we can factorise the second bit as well, just a trinomial. So we've got to have x's at the start because it's only 1x squared. And we've got minus 3, so it means we've got to have a minus and a plus. And the way to get plus 2 is going to be plus 3 take away 1. So that is our answer. Okay. Right, so please leave a comment, subscribe. Let me know if there's anything there you're worrying about. If this is something you're really struggling with, let me know and I can put way more examples of doing synthetic division up. Okay, the next video is more to do with synthetic division and polynomials. However, it should be a little bit shorter. Sorry, this video was quite so long.